All right, welcome everybody. This is our first lecture for psychopharmacology. Before we jump into this fairly short PowerPoint that just really kind of goes, hits the high points of the first three chapters of the book, I want to tell you about kind of how the class is going to be set up along with what's in the description that's in Canvas. So the way I've set this class up is you have obviously the PowerPoints, and then we'll have a lecture to go along with most of them. There's also on Canvas a lot of additional resources that are not going to be they're not going to be tested on your quizzes and your exams, but I think they're very important. Those are things that you really want to you probably want to keep with you, always have available. I kind of have a little book that I keep with me of these resources, comparing antipsychotic receptor affinities or side effect comparisons of antidepressants. And I've compiled those. Some of them I've compiled over the years. Other ones I've taken from other resources, and I just keep adding to them as more and more medications are hit the market. So you want to try to keep those updated. There's several resources that have good options for those, so they're good to have. And then there's also some extra little videos and things that I think that are good for kind of a different way of explaining things. Like for this section, there's some other videos on chemical neurotransmission, which I think do a really good job of kind of talking about the dopamine, serotonin. They get into a little bit of GABA and glutamate. Glutamate is not talked so much about in this chapter, in this section, but glutamate's becoming a big target for psych medications, and we're finding more and more receptors and neurotransmitters that we can target as we kind of whittle down and understand more of how the brain works. So they're good. They're good videos. So there's lots of resources. There are also every Canvas section has a discussion page, and that's just if you have a question that, like, if we were having a class and you just wanted to raise your hand and ask this, because most people probably have that same question. Go ahead and throw it up there. I get notifications on my phone when somebody puts something up there, so I'll answer it fairly quickly. If you have a more specific question, or something about your practice, or a specific patient in mind, you don't have to use that. You can email me directly. I put both my email addresses on the syllabus, so either way is fine. I check my email for Anderson usually on Tuesdays and Fridays. I'll try to check it more often now that we're in the middle of this class, but at least every Tuesday and Friday I'll check it. So if you need something more immediate, you can also send me a message in Canvas, because then it'll pop up on my phone and it sends it as an email. So either way is fine. A little bit about me before we jump in. I'm a pharmacist. I work at Patrick B. Harris Psychiatric Hospital in Anderson. We're a hospital for the Department of Mental Health of South Carolina. We have about 136 bed capacity, inpatient treatment only. Our patients range anywhere from a couple days to several years, depending on their illnesses, their what kind of support they have outside of the hospital, their options for housing outside. They may stay for a while trying to get on disability or things like that. So we have long-term treatment. It's not our facility is not a get them back on their meds and send them out facility. It's very much a long-term. Can the patient afford this? Can we get them signed up for patient assistance? Can we do they have the support outside, whether it's insurance or remembering how to remember to take their pills? Will they do well in a CRCF or a group home, things like that? So any questions, feel free to email me. I still have former students from this class who email me every once in a while, just with kind of random questions, or a new drug will hit the market and they'll say, what do you think about this? Some of the stuff we talk about in these lectures is not going to be on. It's not going to be in the PowerPoints. It's not going to be in your books. It's more if you remember if you were in the pharmacology class this spring, you'll remember I like to throw in the okay, this is what the book says, but in the real world, this is what actually happens. That part of it. So we'll talk about that as we go. The lectures themselves, they'll all be on Canvas. I'm going to go ahead and knock out a bunch of them so that I can stay well ahead of y'all because, like me, I know y'all are working. You have different things put on your time. I try to get these done in batches when when I can get a few minutes, freedom from my kids. So I know y'all have the same things pulling on your time. So that way, if you have an easy week, you can go ahead and knock out some and get ahead if you like. The only thing that's really that won't let you work ahead is the exams. There's a midterm and a final. So other than that, we're pretty flexible. I think that your quizzes, feel free to do them open notes. I do have them timed so that you at least have to be somewhat familiar with the material to know where to go. But I don't think that it's reasonable for me to expect that you memorize everything in this class when there's so much material and you're going to be using it outside. I would rather you be familiar with this stuff and in 6 months you know where to go look, or something catches your attention, like, wait, that doesn't sound right about lithium. I'm pretty sure it actually does this. Let me go double check. As opposed to just blankly, or just memorizing everything in these PowerPoints. So the exams and the midterm are not open book, but the quizzes, they can be open notes, open book. Just remember that there's a time constraint to them. I think that's about it before we jump into the PowerPoint itself and the lecture. The lectures. So this first module is a 1 week module. It's very quick. You can see there's only 26 slides in this PowerPoint. Next week's module, so 2, 3, and 4 are actually 2 weeks long. Those are where we're going to do the most medication. So antipsychotics is next week. I will apologize for how long that lecture is. It is going to be a long one, but antipsychotics can be used for treatment of pretty much anything we're going to talk about this semester. Antipsychotics is really a poor name for that class. Neuroleptics might be a better name because it just modulates serotonin and dopamine and some other receptors. So they work for depression, bipolar, anxiety. You can use them for autism. You can use. There's all kinds of lists. They're usually second, third, or fourth line for every psych illness. So that's going to be a real big one. And then bipolar will be a 2 week, antidepressants will be a 2 week, and then we'll jump into 1 week where the lectures will get back to being fairly short because either it's medications we've already seen. So like anxiety is going to be mostly meds we've seen in depression with some extra ones thrown in there. Or it'll be that there's just not that many treatment options like sleep disorders and ADHD. There's ADHD. We're really going to talk about amphetamines and stimulants, and then a few other backup options, and that's it. That's what we have, and that's very effective. But yeah, these first modules 2, 3, and 4 are 2 weeks because I know there's it's so much information, and those lectures will be long. But I promise after module 4, we'll kind of cut it back down to how we did the pharmacology class, where I'm not going to read you the slides, but we'll go ahead and I'll just give you some extra stuff for each slide and kind of point out the high points. All right, so let's go ahead and jump into this lecture as soon as my computer catches up going to the next slide. Okay, so we're talking about chemical neurotransmission. So neurotransmission is the basis is neurons and the connections between them called synapses. So it's a complex of hardwired synaptic connections between neurons. Synapses can form on many parts of the neuron, not just the dendrites or the end of it. And these synapses are asymmetric, since communication is one direction from the axon, which receives information through the body of the neuron out to the dendrite, the soma, or the axon. So a picture of what you see here of this is, so the soma is the neuron body, the dendrite is the neuron information receiving structure through the spines, which you can see right here, and the axon sends information out. Neurotransmitters are the chemicals that are stored in the axon terminals of the presynaptic neuron. An electrical impulse through the neuron stimulates its release into the synaptic cleft, which in turn determines whether another electrical impulse is generated. So what does that mean? So the electrical impulse comes down the neuron, it triggers it to release a neurotransmitter like norepinephrine, serotonin, or dopamine, which then goes into the synaptic cleft, which is then used to hit the receptors on the next neuron to continue that electrical impulse, that connection to the next neuron. So receptors are molecules situated on the cell membrane that are binding sites for neurotransmitters. You can see there are these yellow markers, these yellow receptors right here on this. So it is released, goes through the synaptic cleft. As it's out here, it binds to the receptor. It may come off, it may bind again, it may bind to several of them, and then at some point it's usually taken up again by the neuron and stored again for later use. So reuptake is the process of neurotransmitter inactivation by which the neurotransmitter is reabsorbed into the presynaptic neuron from which it's been released. Most of your neurotransmitters are, they have reuptake because it's a lot more efficient for the body to reuse those neurotransmitters than to make them over and over again, once they're used. So this will come into play on a lot of our medications. Most people know, like your SSRIs, the reuptake. We're going to block that reuptake, which leaves more serotonin out in the synaptic cleft, so that more serotonin can act on these receptors. But when you hear reuptake, that's what it is. It's bringing those neurotransmitters back into the neurons so that they cannot have that activity anymore, but it's saving it for the next time it needs to release it. So the chemical basis of neuronal transmission, so you have reception, the integration of chemical coding. So basically this is the neuron receiving. It's going to, once it hits that receptor, it's going to turn it into a basic electrical impulse. It's going to go to where it needs to go, whether it's down the axon or down to the synapse, and then signal transduction to the next neuron. So that's the basis of it. We're not going to get very deep into that. But here's where we're really getting into the meat of everything. So 6 neurotransmitters to focus on and psychotropic drugs. Now I do think that these are going to start increasing a lot more soon. The more we start looking at, the more we figure out, we're going to figure out we're going to figure out more neurotransmitters. But the top 6 right now are serotonin, norepinephrine, and dopamine, which most people have heard about. Those are our targets for our antidepressants and antipsychotics and some other classes. We have acetylcholine, glutamate, which is an excitatory neurotransmitter, and GABA, which is an inhibitory neurotransmitter. So you can consider glutamate and GABA are opposites. And GABA, if you need help remembering that, GABA is what benzos work through. So it brings you down, and glutamate is the opposite. So it's excitatory. It brings it up. Glutamate's also being studied now. That's the believed mechanism of action of like ketamine for depression, where the glutamate is excitatory. It actually causes neurons to kind of reactivate, which can then properly send the signal up and down the pathway. So those are our six neurotransmitters to focus on. So impulses move along the nerve. Neurotransmitters formed in the presynaptic membrane and are stored in vesicles. So they're just sitting here waiting to be released. This blue one here is 5-HT or serotonin. The green one here represents norepinephrine or noradrenaline. It comes down, it's released into the synaptic cleft, it stimulates the receptor, comes back up. If there's more receptors, they'll continue to hit. Sometimes it binds and it stays there for a long time. Sometimes it binds and it moves off. That's called a receptor affinity. How well does it bind to that receptor? And that affinity comes into play with our medications also, because not all medications bind the same way. So some may bind and then they kind of do a little, they act and then they release and they'll come back later and bind again, or some bind and never release. And so they inactivate that receptor. As long as that receptor is around, the body will then break down that receptor, bring it back, and create a new one, and that's how you get the inhibition. So it depends on the medication. We'll talk about those specifically when we get to those medications. And then these neurotransmitters are broken down once they're taken back up, they're broken down by an enzyme called monoamine oxidase, or MAO, which you may be familiar with the medications, the MAOIs. So the monoamine oxidase inhibitors, which just inhibits that enzyme that breaks down the neurotransmitters. So it's a way to increase the amount of neurotransmitter you have. So even in these few slides, we've talked about how to increase the amount of neurotransmitter in this synaptic cleft. One, by preventing it from being able to be taken back up, and two, preventing its metabolism, or prevent it from being broken down. So that's how we're getting different classes of medication, which we'll go more in depth on those in antidepressants. I just want you to get a little familiar with those terms right now. But that's why we have different mechanisms of action for different psych disorders, because sometimes one works well for some patients, but it doesn't work well for the others. All right, so neurotransmitters, what do they do? So the big three we're going to talk about right now. Serotonin, it controls vigilance, impulse, appetite, sex, and aggression. And you're going to see there's going to be some overlap in these. Norepinephrine is vigilance, euphoria, pleasure, motivation, energy, anxiety, and irritability. And dopamine is appetite, sex, aggression, euphoria, pleasure, motivation, and energy. So you can see that too much of one of these or too little could lead to adverse events, or either way. So if you have too much dopamine, you're getting too much euphoria, too much pleasure, and too much energy, and too much aggression. Or if you block too much serotonin, you have no impulse, no vigilance, which we'll talk about, like with antipsychotics, those negative symptoms of schizophrenia from medication. Or you may have decreased appetite, or sexual side effects, or a decrease in aggression. So you can increasing or decreasing either one of these can cause adverse events, and that imbalance is what causes psychiatric disorders. And so we need our medications to help bring it back to the right amount, whether it's bringing it up or down. The problem is usually bringing it up or down also brings it up or down in different parts of the brain, which leads to other side effects. So we'll talk about that specifically for each medication. So you can see here how they work together. Norepinephrine, alertness, concentration, and energy. Dopamine, pleasure, reward, motivation, and drive. This one probably not too surprising, because dopamine's a lot of how a lot of our illicit drugs work. So that reward and pleasure makes sense. I would suggest coming back to this slide when we're in certain when we're in the different classes of medication, because you can actually see, like, oh, there's an antidepressant that works through dopamine and norepinephrine only. That makes sense why we don't have any sexual side effects, but it helps with alertness and concentration. Or things like you can look and see how they, why we get some of the side effects we get with these medications. So the medications in general, we have antidepressants that block the reuptake of biogenic amines or neurotransmitters. Antipsychotics that block dopamine, completely block it to decrease its activity, and then also other receptors, depending on which ones. We have benzodiazepines. For those of you not aware, I'm sure you've all seen them, like clonazepam, alprazolam, lorazepam, all of those. They facilitate the transmission of GABA, so they increase GABA's activity, which has inhibitory properties. And we have psychostimulants, which increase the release of those neurotransmitters, like your amphetamine or your methylphenidate for ADHD. It increases the release of those, which for people with ADHD actually helps them to be able to concentrate on things. So this is I just thought this was a very interesting kind of picture on this. It was like chemistry based on what the neurotransmitters do, what the disorders kind of how they're representative. So schizophrenia is too much dopamine, and anxiety is too little, whereas fight or flight is based usually off norepinephrine and epinephrine. So blocking that or decreasing that would decrease your fight or flight. Serotonin is responsible for happiness. So if we block your serotonin, you could get to a spot where it's like depression. So, and you can see that not everything is solely one neurotransmitter and the other. And also, anxiety, dopamine has a role in love, depression, anxiety, and schizophrenia. So you have to weigh all of those things when you're picking an antipsychotic or a medication for a patient, because every medication has some kind of drawback. All right, neurotransmitters, receptors, and enzymes. So 1/3 of psychotropic drugs target one of the transporters for a neurotransmitter. 1/3 of them target the receptors, and about 10% target enzymes. So you can see there's a mixture, which is good because not everybody responds the same to each medication. Using transporters as targets, you can look at presynaptic transporters that are used for the reuptake of neurotransmitters, so we can block that reuptake and leave more neurotransmitter in the synaptic cleft. Each has a false substrate that also works. So like serotonin would be ecstasy, and norepinephrine and dopamine kind of partially work at each one. So you can target the transporter to block the effects of, when we talk about like addiction and substance abuse, you can use these to help somebody come off of it, to treat that addiction disorder. So this action is blocked for those transporters by antidepressants and by stimulants. You also have a presynaptic transporter of choline, which is the precursor for acetylcholine. GABA transporters 1, 2, 3, and 4 are blocked by an anticonvulsant, tiagabine, which isn't commonly used, but it's a good, because we know GABA helps with seizure control, then that explains its mechanism of action. And glycine and glutamate transporters are being studied for schizophrenia right now. So there's some stuff that's in the pipeline that hopefully will hit the market fairly soon, because it would be great to have those as options. G protein linked receptors are a large group of receptors that interact with many neurotransmitters and medications. The receptors are where neurotransmitters act to produce certain effects. So it depends on which neurotransmitter, where in the body, and which receptor is hit. So when we're talking about those, we're talking about how does it hit it. Is it an agonist, which if you were at the intensive in the spring, we already talked some about this. So an agonist turns on the synthesis of the second messenger to the greatest extent possible, or it activates that receptor as much as it can. It is what that receptor is made for. It hits it, and it is able to fulfill its action that it needs to. So a good example is for a dopamine receptor. Dopamine itself hitting that receptor provides the full effect. You can have antagonists, which blocks the action of the neurotransmitter. It doesn't turn that receptor off. What it does is it just comes and it essentially creates a dam, or it just covers that receptor so that dopamine can't come and hit and activate it. So it doesn't turn it completely off, it just blocks it. It'll continue as if nothing is binding to it, but the binding site will be blocked. A partial agonist is somewhere between an agonist and an antagonist. I know it's not surprising. It's a good name for it. It's a partial agonist, but it gives a subdued response compared to an agonist. So it can be anywhere on the spectrum, and a good example of this is Abilify. So Abilify or aripiprazole is an antipsychotic that's a partial agonist at the dopamine receptor. So it comes in and it activates the receptor a little bit, but won't let it be activated completely, so that we get some dopamine effect, because we need that for normal functioning. But it doesn't block it completely, but it doesn't let it act as much as it wants to, which is where we get, how we get the hallucinations and delusions and those positive side effects, those positive symptoms of schizophrenia. And an inverse agonist, which you don't see very often, but it is a way that medication works, is it completely inactivates the receptor. So it produces a signal less than if the agonist or antagonist is on it. So in the range of no action to action, you get inverse agonist, antagonist, partial agonist, and agonist, going from no action to the receptor to full action. Medications are also used as target. Our enzymes are also targets of medication, because medications are usually inhibitors of enzymes. They may be reversible or irreversible, and that's important. Sometimes it's reversible, so when the medication wears off, that enzyme is able to continue to function, or it may be irreversible, where that enzyme cannot function until the body breaks it down and creates that enzyme again. So that is going to affect how long and how effective that medication is. Examples are MAOIs, or monoamine oxidase inhibitors for depression, acetylcholinesterase inhibitors for dementia, and glycogen synthase kinase inhibitors like lithium that's used for bipolar disorder. Cytochrome P450 enzymes. I'm not going to go into this in depth, because we did talk about this in your intensive, and there's a lot of information on Canvas about this, but these are very important. We will talk about these in almost every section this semester, because our psych drugs are not clean medications. They have a lot of drug interactions. So we're going to be talking about these a lot, especially cytochrome P450 1A2, 2D6, and 3A4. So definitely go ahead and read up on those so that you're familiar with them as the semester goes on. Epigenetics, just real quickly. This is an interesting topic, that genes exert significant control over behavior, since mental processes and the behaviors they cause come from the connections between neurons in the brain, and that behavior can also be a modifier of genes. So what this really says is that experiences, education, psychotherapy may alter specific synaptic connections and lead to long-term genetic changes. This is thought to be one of the reasons why, some people can go through the same traumatic event, and some develop PTSD and some don't. You're genetically, you are genetically more predisposed to developing those side effects. Also it may explain why, we know that obesity is a trigger. For example, obesity increases your risk of diabetes, but not everybody who's obese develops diabetes. So it helps that you're genetically predisposed, and then the actions and and things you come into contact during your life either trigger or turn off certain genes, which is why you have different outcomes, and there's a correlation, but not a direct cause for those things. So this is just an interesting topic. So that is it for the first module. Next, we'll talk about antipsychotics. It's going to be a fairly long one, but it's very important because of how much we use those medications. If you have any questions or anything, just send me something through Canvas or shoot me an email.